Continuing lesson 5-6, solving two-step inequalities, page 291. Once again, very similar to solving equations, only difference is at the end, if you have to multiply or divide by a negative number, then you have to switch your inequality signs around. So, on this problem, the first thing you may want to add the opposite. We need to see that as a negative 9/2 x. And then our goal on the two-step equations, first thing is to try to get the x term or the variable term by itself. So to get, in this case, negative 9/2 x by itself, we've got to get rid of this negative 10. To get rid of the negative 10, we would have to add 10. Okay, generally on your problems here, your first step is going to be that you're either going to have to add or subtract. The second step usually is going to be that you're going to have to multiply or divide. Almost every problem will be like that for you at this point. So at that point, we added 10, we get 90. And then the book's doing it a different way. The other option, like we've talked about, you could say they're multiplying, so we could divide by negative 9/2. Now remember, when you're dividing by a negative, that is where that sign switch is going to happen. Sign's going to change directions here. And remember, dividing fractions is keep, change, reciprocal. Good. Usually the negative sign will put up with the numerator. And then if you wanted to, since you're multiplying fractions, you have an option of reducing these if you'd like. Or you can just multiply across, you'll get negative 180 over 9 and then divide that out and you'll get the same thing, which would be negative 20. So x is greater than negative 20, and then they didn't ask us to graph this. If they did, it would be an open circle at negative 20 going towards the right. So similar idea if we look at the try it. So you can go ahead and add the opposite here if you want, and then see if we can solve this. So to get our variable term by itself, this is a positive 5. If you want to, you can put a plus in front of it to indicate it is a positive 5. And to get rid of that, we would need to subtract 5. I know it looks different, but it's really like they're adding 5, we need to subtract 5. It's just in a different order. So you subtract would be 25. So our second step, we could say they're multiplying by negative 1/2. Let's divide by negative 1/2. Once again, we've got to remember we're dividing by a negative, so the sign's going to change directions. And again, dividing is keep, change, reciprocal. If you want to put the negative up with the numerator, when you multiply, that'd be negative 50 over 1, which is the same as negative 50. So x is less than negative 50. If they ask you to graph it, it would be an open circle at negative 50 going towards the left. The key concept, one thing just to make sure we've talked about this, is that two-step equation, we get one answer. X equals 5, y equals negative 7. One answer. With two-step inequalities, we have multiple solutions and potentially infinite solutions. Okay? That's where when we graph it, you draw on a number line. Like if we get x is greater than 1, and I graph that, anything greater than 1 would work. So, you know, especially if it's not a real life problem or we don't really know what's happening here, we're going to assume any number greater than 1 works. So we could have 1.5 could work. We could have 50. We could have 10 million. Okay? anything would be fair game there, unlike equations where we only have one answer that works. If we look at the do you know how number 4, Joe ran 3 miles yesterday and wants to run at least 12 miles this week. Write an inequality that can be used to determine the additional number of days Joe must run this week. If each run is 3 miles, then solve the inequality. So we could define a variable. So we could say let x represent the additional days that Joe runs. And we could just think of something general here. So we could think about what he's already run. How far he's already ran, I guess we could say. And then plus what he's going to run. What he's already ran and plus what he's going to run. And then he wants at least 12 miles. At least 12 miles total. So he's already ran 3 miles. He's going to run, it tells us 3 miles a day. So 3 miles a day times however many days that he's going to run. And this total needs to be at least 12. This total needs to be then greater than or equal to 12. So once we have that set up, the first step is we're going to subtract to get that variable term by itself. So 12 minus 3 is 9. At this point, they're multiplying by 3. We need to divide by 3 on both sides. And 9 divided by 3 is 3. So x is greater than or equal to 3, which means that he needs to run at least 3 more days. And when we answer that, we really should write a sentence out. Don't just get your answer and then move on to the next problem. Write a sentence explaining what the meaning of your answer is. Number 6, Thomas has $1,000 to spend on vacation. His plane ticket costs $348.25. He stays 5 5/10 days at his destination. How much can he spend each day? Write an inequality and then solve. So first of all, we should probably define a variable here. So if we let D represent the number of days on vacation, we've got our plane ticket. We're going to assume is a round trip plane ticket here. And then plus 5.5 times however many days. Sorry, this should be the money spent per day, actually. And then this needs to be less than or equal to 1,000 for him to stay in budget. He has $1,000, so the amount he spends has to be less than or equal to 1,000. In order to solve that, once we get that set up, they're adding. So we need to subtract 348.25. If we were doing this by hand, remember our decimal points would have to be lined up. When you subtract is $651.75. And then if you divide that by 5.5, remember we're not dividing by or multiplying by a negative here, so don't switch your inequality sign around. When you work that out, should be less than or equal to 118.5, which means $118.50. And again, we could give a sentence description there. He can spend up to $118.50 per day. So look at number 7, solving this inequality. So since they're subtracting here and the variable is right there, might be a good idea to add the opposite. If these were reversed, and if it was like 12x minus 3.5, then I wouldn't necessarily bother adding the opposite. I would say they're subtracting, I'm going to add. The problem is we're not trying to get rid of the variable term, we're trying to get rid of the other term. In this case, the 12 here. Once again, the 12, we know it's positive. If you want to put a plus sign in front of it, you can, to think about that that's what you're going to be getting rid of. So since they're adding 12, essentially we need to subtract 12 on both sides. And again, we need to see that as negative 3/5 x is greater than 27. At that point, they are multiplying, so we can divide by negative 3/5. Dividing by negative is going to switch your sign around. It's going to go to less than. And again, dividing is keep, change reciprocal. You usually put the negative with the numerator. Once again, you have the option, since you're multiplying now, you have an option of reducing like factors. And that would be negative 45. Otherwise, you can multiply and get negative 135 over 3 and then divide that out and you should get the same thing. And it just said solve. It didn't say to graph this, but it would be an open circle going to the left if you did. Workbook page 72, if we look at number 6. Amelia can spend no more than $89 to rent a car for a day trip. Rental car costs $35 per day plus 20 cents per mile. Write and solve an inequality to find the possible distance in miles m Amelia can drive without exceeding her budget. So they already defined the variable for us. M is the number of miles she can go without exceeding her budget. So we're going to set up an inequality here. So we have basically a cost of the rental car, just the car part, and then we have mileage. I think that's how you spell that. And that's basically a cost based off of how many miles that you drive. Okay, so those two parts together, she can spend, this is the amount that she's spending. If she can spend no more than $89, that means these two together should be less than or equal to 89. Okay, and that's how the budget problems generally are going to be. It's going to be as a less than or equal to. So our rental cost here is $35. The mileage is 20 cents per mile, so that'd be 20 cents times M, and that needs to be less than or equal to 89. Once we get that set up, we're going to try and get our variable term by itself. So we need to get rid of the 35. It's a positive 35, so we need to subtract 35 on both sides. And then they're multiplying, so we need to divide by 20 hundredths or 20 cents. Again, we didn't divide by a negative or multiply by a negative, so our sign stays the same. And when you work that out, it should be 270. So less than or equal to 270. So we could say something like she can drive up to 270 miles, she can drive 270 miles or less, something to that effect. So this gives you an idea of how to solve two-step inequalities.